Guys, and welcome to a brief exposition on waves and the nature of light. First, let's start off with waves. So what is a wave exactly? No, not that kind of wave. Simply put, a wave is a transfer of energy from one place to another. There are two different kinds of waves: electromagnetic and mechanical. Let's start with mechanical. The important point to remember about mechanical waves is they need a medium to travel in, but they are all around us. A special classification of waves would be the periodic wave. This is a wave that has a constant pattern to it. A fine example would be the solar cycle of the sun. If a scientist were to look at the graph of the solar cycle and study a single disturbance, he would be looking at a pulse of the solar graph. Waves can also be classified by how they move. First, a transverse wave. In this wave, the particles move perpendicular to the wave direction, like so. Here we have the wavelength, which is the distance from one crest to another, and here is the amplitude, or the distance from a crest to a resting position. If we measured the number of crests in a given time, we would find the frequency of the wave, which is measured in hertz. Using the frequency, we could then find the period, which is the time it takes for a successive pass of a wave's crest by a single point. A different type of moving wave is a longitudinal wave, which has particles that move parallel to the direction of the waves that are traveling. This wave is made up of compressions, where the particles are closer together, and rarefactions, where the particles are well separated. Another type of wave classification by its particles is surface waves. The wave combines transverse and longitudinal waves to create a circular or elliptical movement of the particles, much like the waves on the beach. Finally, we arrive at standing waves. This wave occurs when both ends of the waves are fixed, like two people waving a jump rope up and down. A standing wave has two parts: the nodes and antinodes. A node is where the amplitude is 0, and an antinode is where the amplitude is at its maximum value. When we want to know how fast a wave is traveling, we want to find the wave velocity, otherwise known as v. V can be found by multiplying the wavelength times the frequency of the wave. Another important math component to remember is that the frequency and period of a wave are inverse to each other. So 1 over the frequency equals the period, and 1 over the period equals the frequency. But what happens when waves meet? There could be two outcomes due to the law of conservation of energy. There is constructive interference, in which the waves and their amplitudes together create one larger amplitude. And then there is destructive interference, where the waves meet and their amplitudes subtract and equal 0. But what happens when a single wave hits an object that is blocking its path? Diffraction occurs, when the waves spread around an object. So this whole time we've been talking about waves, and one of the most important things in our universe measured in waves is light. But what is light? Well, due to the duality of light, it's really two things, both a wave and a particle. Young's double-slit experiment proved that when it was a wave when he saw that the fringes of his experiment were produced by destructive and constructive interference. Then Einstein proved with the photoelectric effect, because he saw the light was emitted by particles called photons. So thank you very much for listening, and we hope that this video made you a little brighter. The end.